Jeremy, can you hear me?
I can.
Okay, finally. Phew. How you doing?
Doing all right, thanks. How are you doing today?
Good.
Take the barrel vault of that ceiling behind you.
Yeah, that's our Gould Evans office.
Awesome.
Yeah. We're starting to come back fairly regularly.
Yeah, I've been in maybe 2 or 3 days out of the week on average the last few weeks. It
Yep.
helps a lot having having kids in summer camp.
Oh yeah, I bet.
So I'm going to go here, do this.
So Jeremy, you know how this works?
Yeah. Hey. So Galen is going to give an introduction, and then we'll
Okay.
start running through. Yep.
Just curious. Last time I got involved, we were at the tour last week. So,
Yep.
and I know Daniela is not able to join. So,
Gotcha.
yeah. All right. Cool. I'm assuming camera's on.
Yep.
All right, there you go, Robert.
There's Dennis. Doesn't look like you're in Rancho Bernardo.
I'm all over the place these days.
That's good.
Jeremy, do you know if Kristen's going to give us the thumbs up to start, or if we're just going to make that call?
I just messaged you, Galen. You may go ahead and start.
Thank you.
And Jeremy, just note that Dennis Astle from Palomar is in the attendees list and not the panelist list, which is probably backwards.
All right, we're going to go ahead and get started. Good afternoon. My name is Galen Liff. I'm an architect here in Kansas City, part of the Design Awards Committee, and I'm going to introduce what we're doing here today. On behalf of the Design Excellence Awards Committee and AIA Kansas City, I want to welcome everyone and thank you for joining us today as we learn about a fantastic project and one of the AIA Kansas City 2020 Design Excellence Award winners. Each year, we receive a lot of fantastic design award submissions, along with a lot of requests from our members to have more in-depth discussions about some of the projects selected as winners. In response to that, we wanted to showcase some of last year's Design Excellence Award winners as part of a Show Your Work series this year. The Palomar College projects by BNIM that we're about to see certainly rose to the top, especially when it came to addressing the top 10 sustainability measures portions of the submission. So thank you to BNIM, AIA Kansas City, and AIA San Diego for putting this together as we take a virtual tour of the Palomar Community College Maintenance and Operations Complex. Representatives of the project owner, architect, engineer, and construction teams will guide us through a virtual walking tour of this extraordinary community college maintenance facility project. For a brief description of the project, Palomar College is a public 2-year community college in San Marcos, California, approximately 30 miles north of San Diego. And while the campus operations facilities are often relegated to secondary locations, this project is located on what was an existing surface lot at a highly visible campus gateway. The design challenges the typical maintenance and operations building typology by creating a positive, high-performance campus environment that centers on human purpose design. It was designed as a net zero building and was also designed to achieve LEED Platinum certification and to become the first living building petals certified community college building in the world. Palomar Community College set out to design and construct a new home for the facilities department, previously stretched out across 8 separate buildings. The design team worked closely with the college to demonstrate how strategic, high-performance design strategies can simultaneously fall within a given budget while increasing the lifespan of a project as well as its value over that time span. From the design and construction of the net zero building to the use of innovative landscaping strategies, the maintenance operations complex acts as a teaching environment in and of itself, meeting the college's mission by showing students what it means to live responsibly and contribute globally. I personally look forward to learning about the specifics of what they're able to achieve and how we might collectively apply some of those strategies to our very own projects. So please ask your questions in the chat and someone will be moderating them at the end of the tour and presentation. Also, a reminder that this program is worth 1 HSW if you stay with us for the entire duration of the program. And now on to the presentation.
Great. Well, thank you, Galen. My name is Jeremy Knoll. I'm with BNIM Architects, and this is our agenda for today. Galen has just introduced us. I'm going to run through a brief project overview. Then we're going to go to the virtual tour. And based on schedules, we ended up pre-recording this, but I think that helped us cut down some of the time in between stops and so forth. So it's pretty great. And then we're going to talk. I wanted to make sure that talking to a primarily Kansas City and Midwestern audience, that we weren't only focusing on a Southern California project, but figuring out how the strategies we use there translate into our market, into our climate, but using a similar project type. So we'll go through a few recent and current projects that built on the lessons learned from the Palomar project, and then we'll end with some questions and dialogue to the team. So please ask your questions in the chat, as Galen noted earlier, and we'll pick them up towards the end here. So this is the team that you'll see today. I introduced myself already. Danielle Budakavi is an associate principal with BNIM. Jeremy Kam will be joining us in a little bit as well. He was also an associate principal with BNIM. And then since you all three are here, I'll let you each introduce yourselves if you want to go off mute. And I want to start with Robert.
Sounds good. My name is Robert Pagnon. I'm an associate partner at Susquehanna in San Diego. We were the MEP engineers for the project for BNIM.
Good afternoon, everyone. My name is Dennis Daly. I was a project manager on this job with Level 10 Construction.
And good afternoon, everyone. My name is Dennis Astle. I'm the manager of construction and facilities planning for Palomar College.
Great, thank you all. So a maintenance and operations complex isn't always what you think of when you're thinking about a beautiful, high-performing space, but that is what was delivered here. And just a little bit about Palomar Community College. The mission is to provide an engaging teaching and learning environment for students of diverse origins, experience, needs, abilities, and goals. And while these types of buildings are often relegated to spaces sort of in the back or behind buildings. You can think of like the prefab metal kind of Butler buildings that I'm sure we're all familiar with. In this case, the location of this building was right near the front of the campus at a gateway to the campus itself. So the design integrates traditionally segmented shop spaces, office spaces, and warehouse space into one facility. And so we'll give a little bit more detail as we go here. As Galen mentioned, this is an urban 250-acre campus about 30 miles north of San Diego. And you can see here the community college is kind of where this little cluster of pins lives here. And so to the west, you can see that there's some single family housing. To the south, there's commercial and light industry. And then both east and west, there's more single family housing. But you can see that this gets right up to some natural aspects of the California coast as well, that we'll talk about in a little bit here as well. So zooming into the campus plan here, I wanted to highlight a few particulars. Number one is that this along the south is sort of the main drive and entry to the campus. So you've got an entryway right here, right next to the new maintenance and operations complex. Now the maintenance and operations complex used to be up here towards the north end of the site, spread out across several different buildings. And taking up quite a bit more space. And then just because it'll become important in a little bit, I also wanted to point out the Level 2 Arboretum on the campus, which became a pretty important aspect of this project as well. So high performance design strategies are realized by collaborative, interdisciplinary teams working towards a shared vision. That's really what it takes to produce this type of building. The design of the maintenance on operations complex provides a diverse user group and active high performance workspace that fully utilizes innovative and passive design principles. The maintenance and operations complex is 28,000 square foot project located at the gateway of the community college, and the building serves as the grounds and maintenance division for the entire 252 acre campus. And so before I go away from this one, you can just kind of see for a moment here that we that there is a large solar array bridging between two separate elements. There's some a pretty detailed native planting system that runs through the entire complex with pathways that connect to the surrounding communities and to the college itself. So programmatically, the design integrates traditionally segmented shop areas, spaces, office spaces, and warehouse spaces into one place, as we've said. The spatial diversity that is offered by putting these together allowed the project team to reallocate some of those costs from that would traditionally be with separate mechanical systems into and put some of that money back into the facade of the building itself. And we'll talk a little bit more about why we did that and the benefits of it in a little bit here. But as you can see, in the basic form, there's a maintenance bar along the top, a courtyard, an outdoor space in between the buildings, and then an operations bar. And so programmatically, the way that this breaks up, you can read along the right. I won't read all that out here, but the facility department includes grounds, maintenance, custodial services, vehicle repair, and much more. And the team worked with Palomar staff to map the many vehicular and maintenance circulation patterns as well in order to optimize the performance of the facility while reducing the vehicular footprint. So that was happening both on the hardscape side as well as finding synergies and optimizing for the interior space as well. And the net result of that was a 19% reduction to the overall, to the existing maintenance and office facility spaces. Talking a little bit more about site topography and orientation, BNIM used the site topography and the strategic placement of the facility within the land and landscape to screen vehicular uses and to create a series of memorable indoor and outdoor spaces that are visible from both the pedestrian and vehicle entries on the campus, but also from those offices and spaces inside looking out into natural landscape. The landscape plan features primarily trees, plants, shrubs, cacti, and I think it's important to also say that this place, before we developed this, was a surface parking lot, as has been mentioned. But prior to that, before anybody developed here, this was an existing ecoregion known as a montane chaparral and woodlands ecoregion. And so a lot of the landscape work was dedicated to reproducing as carefully as possible that type of landscape, which includes shrubs, cacti, ground cover, oaks, and many other plants that are either native or naturalized to this place and planted in kind of a patchwork. The pollinators, fruit-bearing trees, native grasses, and shrubs wrap the building and interrupt the paved areas in the patchwork common to this biome. And luckily for us, in developing this type of ecology and landscape, the college actually has a botanist on staff who is actively maintaining these spaces and thinking about things like hydrology, soils, and landforms that they grow in to really optimize this landscape to closely match what was there before. The living laboratory is shared with the public through introducing the pathways, simple seating, and other opportunities so that wherever you are on the site, you're a few steps away from being surrounded by nature. Again, not what you think of with a maintenance and operations facility. So the collection and reuse of water was the inspiration for a lot of the landscape features here and provides the basis for the layout of the site. The hardscape areas, the capture and conveyance of water is interpreted as formal channel elements, cisterns, the courtyard water garden, all capturing condensate and rainwater from the overhead shade structures. And then in the softer areas, the water elements become more like creek beds or natural systems that during a rain period really explode with natural color and flowers. And you can see along the right here, the sort of full list of the types of spaces here. I will say that as part of the Living Building Challenge coordination work, there were some very specific rules about how do you lay out a parking lot, what are the distances, how much planting do you need. So some of this was dictated by the types of certification that we were looking at, but for the most part, this was trying to match that original biome. So the project uses a unique passive design system to embrace the Southern California climate. And so we're using a narrow building footprint, providing access to the year-round optimal temperatures within the buildings, and then using things like solar chimneys, roof monitors, and fans and Solitube to create both comfort and light within the building itself. Along the left here, just to go through it from left to right along the numbering here, we've got overhead sectional doors with operable louvers along the north side of the warehouse building. We have Solitube and ceiling fans in the middle of the space, so providing both natural light and moving air over air conditioning first. And then operable windows as well. So wherever you're sitting, you've got access to some operability. There are also thermal chimneys that are really utilizing the stack effect to passively heat and cool the space depending on the season. Aluminum roof monitors, again, to let more light in and air out. The PV sun shading system, so it's both collecting energy and shading the building. And then the dual harvesting sunshade system and a bioretention basin. So really a lot going on here. And ultimately, we're in the last stages now of completing the Living Building Challenge version 4 PETAL certification. Boy, that's a mouthful. And looking at energy, place, equity, and beauty as the target petals for this facility. So just a couple of things to share on this is that due to the use of passive systems and envelope improvements here, these yielded an 85% reduction in the cooling hours necessary for this building and approximately a 30% cooling load reduction. It's along the north side of the warehouse. South facade, the east facade. And looking at the part of the Living Building Challenge is collecting the real world energy use and production of a project. So looking at, although last year may certainly be an anomaly since the building wasn't occupied for the entire year, looking at the energy use between September 2019 and September 2020, the building used a grand total of 152 megawatts of energy, but it produced 294 megawatts of energy. So about a 93% net positive beyond the net zero. And again, that's with March through September being partly occupied as a campus, but I know Dennis will tell us that they were occupying and there was still things to maintain on the campus. So that's not zero occupancy, it's partial occupancy. So we're gonna switch now to our virtual tour. Laura, I'm going to stop sharing if you want to share your screen.
Hi everyone, this is Danielle with BNIM and we're excited to be here at our Palomar project with Palomar College to take you on a tour of our Palomar Maintenance and Operations building. I'm here with Dennis Astle and we're sitting in kind of next to the landscape area, and the bioretention area is just behind us, and then you can see the building in the distance. This is kind of one of the entrances to the project. It's really visible to sort of people coming into the campus from the southwest. So it was really important to kind of re-envision this entire space. It was formerly a parking lot, so this project was a great opportunity to transform the existing parking lot into this gorgeous landscape that you see that we're sitting in, and then with the building set back in the distance there. Dennis, why don't you talk a little bit more about the project?
Yeah, one of the primary goals of this project was to change the appearance of the facilities building. We came from the far north end of campus, kind of hidden in a bunch of ragtag buildings, and we've moved to the very front corner of the campus on two very busy public streets. So one of our requirements was that this building be atypical of most facilities and maintenance buildings. It had to be aesthetically pleasing because it is now the new front door of the campus. And as you can see, the building turned out phenomenally well. really a drastic improvement. And with the landscape here on the south side, it's just a beautiful setting for the campus now for people coming in.
Great. And in terms of the landscaping, the entire site is about 50% softscape landscape. So it really does a great job to kind of reduce the expansive paving and reduce the whole urban heat island effect as well. The majority of the landscaping is drought tolerant and native species, so a lot of the xeriscaping. It does also incorporate some of our water harvesting, rainwater harvesting, and stormwater strategies. So we're able to harvest some rainwater, and we'll talk about that a little bit more when we walk up towards the courtyard. But you can see the rainwater that we don't have harvested comes down into this bioretention area that sort of comes down to the south of the project. The other great opportunity was to be able to tie the landscaping in with Palomar's Arboretum.
Yeah, what is unique about our campus, this entire campus is actually a certified level 2 arboretum. So the landscape had to fit within our overall master plan for the arboretum and really be specifically formulated to tie in with the surrounding landscape as well and add to the collection. And our ground supervisor, Tony Rangel, will explain that a little more in depth.
So my name's Antonio Rangel, or Tony Rangel. I'm the ground services supervisor here at Palomar College, and I'm also the president of the Friends of the Edwin and Frances Hunter Arboretum here on campus. You've already heard that the campus is a certified level 2 arboretum, and so in doing that, we wanted to continue having a diverse plant palette here on this project. We thought it was a great opportunity to incorporate a lot of California natives, kind of incorporate drought-tolerant specimens. So much of what you see behind me is exactly that, but we also wanted to add a few other geographically isolated plants from other regions. So for instance, as I mentioned, we've got a lot of California natives in here, but there are some drought-tolerant desert southwest plants in this area here. And then over on the other side, the far side, which I think we'll get to see today, I'm not 100% sure if we're going that way, but we're going to get to see some of South African plants, and those plants are come from a habitat very, very similar to the coastal sage community, which we actually have here on the hillside surrounding the campus here in San Marcos. We also took an opportunity to plant some edibles. We always try to incorporate edible plants into the landscape whenever we're planting on campus. And actually, a lot of the edible plants, especially here on this project, we've been able to harvest the fruit and send them to our food bank and nutrition center to help out the students who may or may not be in need. And that's been successful. As the plants grow and start developing more fruit, we're going to have more opportunities to do that. There's a small section on the far side that has some hybrid plants, so some hybrid palms, some hybrid trees that are native to California and the desert southwest. Some of the hybrid palms are from South America. But again, it's just trying to create an aesthetically pleasing environment, trying to utilize and incorporate drought-tolerant plants as much as possible. Trying to make sure that it's as low maintenance as possible is another big thing for us. And then an educational opportunity.
From this vantage point, you can see how we designed the building to relate to the existing campus with the terracotta panels. We picked from a color palette that's kind of authentic to the terracotta paneling, but also relates to the brick and CMU work that's on some of the existing buildings that you can see kind of across the street in those campus buildings there. So the building really kind of relates to the existing architectural aesthetic on campus in that texture. On kind of a trail network that goes around the project and connects to the campus and the existing community. So we're just going to kind of walk around the building and talk about some of the architectural features from the courtyard. here you can see the courtyard that sits between the two buildings. On this side, this building consists of mostly the office spaces and the reception area. So a lot of the more kind of quiet, focused work is on this side. And then across the courtyard, we've got a lot of the shops and the warehouse for the maintenance and operations staff. So some of the louder activities happen on the other side. And then sort of the more collaborative spaces, conference rooms, the reception area and the break room are all kind of facing this interior courtyard area. And the main entrance to the building is also within this interior courtyard area. So it really kind of promotes the active use of this area. And we've also designed the building so that it captures a lot of the predominant west-southwest winds. So we are kind of getting the best of the microclimate here. And then with the canopy that you can see up above, that's where our PV panels are. That creates a lot of really great shade for this interior courtyard space. So it really creates a great kind of outdoor climate for everyone on campus to use here, where you've got the really sort of nice cool breezes coming from the ocean and then sort of the shade from the sun. So it really kind of promotes the use of the outdoor space. By sort of separating out some of the programs, we're also bringing people out of the building to kind of walk across to the break room or walk from the shops over to the offices. So it really gives everyone an opportunity to kind of get out of the building and sort of, you know, experience that outdoor, the outdoor climate and really better connect to nature as well. Now I think it would be great to hear from Robert with Syska to talk about some of the energy and water strategies that we have for the project.
Hello, I'm Robert. I'm with Syska Hennessy Group. We were the MEP engineers on this project with BNIM Architects. And I'm going to talk about a little bit of the environmental conditions that we worked with the architect on with this project. First, the building itself, when we talk about the environment, it's located in somewhat of a transitional zone for the county, from the coastal to the inland valleys. And one of the important features that is part of this building and the capture of rainwater is the roofing systems. The roofing systems allow for the early morning condensation of the air onto the surface of the roof, and then that condensate is then collected and brought down the roof drains into cisterns on the side of the building. Those cisterns gather both rainwater and condensate that's brought out of the fog in the morning and then used to irrigate the plant materials in the landscape. In addition to those features, other features that were built into the building include solar chimneys. Those solar chimneys help draw in warm air and suck it up out of the building and pull in cool air through the base of the building. You can see some of the open windows at the bottom of the storefront glazing. Those are automatically opened in the morning. They suck in cool air. The thermal effect in the solar chimneys draws the air up and through the building. It's part of both of the maintenance block and the office block buildings to allow for that natural ventilation. We'll talk a little bit more about that later. That natural ventilation system, the combination of the lighting control systems and the bifacial PV allow us to have a ZNE building, zero net energy, or even energy positive. They're creating more energy than they're actually using within the facility. So it's all part of the strategy moving forward.
Hi everybody, my name is Dennis Daly. I'm a project manager with Level 10 Construction. We teamed up with BNIM and Syska to build this beautiful structure for Palomar Community College. I'd like to talk to you guys about a couple things. First thing was the design build portion of it and bringing a general contractor in with the team at the beginning of the job to allow us to run pricing exercises on different options, because when we bid this project, we had a vague idea of what we wanted. meeting up with the design team, meeting up with all the end users, allowed us to get a better understanding of exactly what they wanted, where to put it, and how to put it there. One of those good option with that was these exterior terracotta walls, which Danielle said earlier is bringing in other design aspects that the community college already has. But what exactly did we want to put on this wall? So we had ideas, we had options. One was a concrete tilt-up wall, one was a steel structure, and one was a frame structure. They all had their positives and negatives, and we put together A3 reports or good, better, best reports and pricing with those in order to come up with the best option for the design team, for the budget, and for the community college. What we settled on was the tilt-up walls due to the cost effectiveness, the thermal abilities, and the attractiveness of it. So this is where we ended up.
The tilt-up wall panels, in addition to the terracotta rain screen, really gave us kind of the best of all worlds from a cost, constructability, time, and performance aspect, and also the gorgeous aesthetic that we ended up with. Also wanted to talk about the landscaping in this area. As you can see, Robert pointed out the rainwater cisterns here. And so those collect rainwater, and rainwater that doesn't get collected comes out into the sort of water channels that you can see. It runs here underneath this bridge and then travels that way and actually connects south of the office bar as well. So there's more sort of water intensive plantings in this water collection channel. And then as well, the landscaping that's in the middle of the courtyard, we were looking for plant species that will really thrive within a more shaded environment. So we get a little bit of diversity in the landscape species that we were able to design for within this project. Next, we're gonna walk over into the warehouse to take a look at the thermal chimneys from the inside, and also some of the programmatic strategies that we had there. You can see through the building down this corridor. We designed the building to have kind of a specific width to really kind of capitalize on the natural ventilation through the building, as we've got openings on both the north and the south side. So it's deep enough to allow that natural light and natural ventilation really penetrate the interior. And then we also have this corridor to kind of connect both sides of the building so that all of the activities that are happening here on the north side, people can easily walk to the other side of the building and connect to the central courtyard and the office bar to the south.
One of the more interesting items installed in the entire building is the movable storage rack system in the warehouse section. During the design build process, we were able to figure out how many square feet the existing warehouse had for storage, and went through a design build process where it was cost versus storage square footage. And what we came up with was the most cost-effective option to keep the size of the building where we wanted it inside of the budget and get them the storage space they need was the movable storage system. And the crazy thing was DSA had never seen one of these before, whereas opposed to our military who stores missiles on these things on a daily basis. DSA had never seen it before, so we had to go through that design process with DSA, and this is the first DSA approved movable storage system on any college in the United States.
And it was really instrumental in helping us gain space efficiencies from a program space. So the original requirement for the building in terms of the square footage was around 34,000 square feet, I believe, and we were able to bring that down quite a bit because of our ability to maximize space for the storage using our movable racking storage system. So this was really important in helping us just be more efficient with the space, and so that we could kind of better use the overall site and meet sort of the 50% landscaping, 50% hardscape requirements as well.
And another item, keeping with the combining groups who get the most use out of things. The janitorial side is right there with the roll-up door because janitorial receives the most paper products and cleaning products. So we were able to combine these two groups and give them access through the space. In addition to that, we also put the loading dock out front because everything comes to the warehouse. They didn't have this before. Now they got a nice loading dock to be able to quickly and efficiently unload a truck. If it needs to come into here for storage, they can do that. If it needs to go outside in the back for immediate pickup from someone else on the campus, they can do that too. So a lot of efficiencies were built into this space just by figuring out where all the most efficient and most used groups need to go.
And that was really due to a process where we had input from all of the end users from the very beginning of the design process. So in the beginning of the design process, we had a series of workshops, including a lot of staff from the maintenance operations to understand what their requirements were, what their needs were, so we could figure out how to locate the spaces on the site that provided kind of the most efficiencies for their day-to-day tasks.
Hello again. We're inside the warehouse or maintenance block building, and we are standing in front of one of the solar chimneys that's an integral part of the natural ventilation system. And you don't see much of it from the inside. You've got the storefront glazing, but as you pan upwards, you can see the chimney up there. This is where the solar effect takes place. It heats up the air early in the morning, and that creates an effect that draws in the cooler air from below. You can see below me there are operable windows. These are automatic. They open up at the right time of the day to let the cool air in and to create that ventilation up through the chimney. Additionally, the warehouse doors on the opposite side of the space open up, and that draws the air across the space and then upward into the heated air up and out, and creates the natural ventilation effect. In concert with that, we do have some ceiling fans. These large fans help circulate the air and keep the air from stratifying. So it takes the heat from the ceiling and pulls it out and allows it to again ventilate out of the building.
With these really tall windows, one piece of the thermal chimney is that we've got low E glazing from the 10-foot datum down to kind of prevent heat gain happening lower down, and then clear glass above to let the heat come in at the top so that the hot air up there helps to pull the air sort of through the whole space. So like Robert said, it really helps to naturally ventilate the space, pulling that air, pulling the cool air down from the outside, kind of lower to the ground, and then pulling that up and out the chimney at the top. We've also got sort of the exterior white sunshades that you can see, so that really helps prevent kind of direct sunlight entering in the space down here, so we get sort of the nice diffuse natural light quality coming into the building from the south side here, and then also with the doors open on the other side of the warehouse, we get the natural light coming in on the other side of the building there. So really maximizing the natural daylight and also the natural ventilation throughout the space.
Views to the outside world for spaces. Also visually from the outside, architecturally, it's the front door of the building, you see it, and the glazing creates this visual interest to the facade that you wouldn't normally have.
Right. And through the glass, being able to see to the outside also reinforces that connection to nature and the exterior as well. So So we're standing on the south side of the maintenance bar, taking a look at the thermal chimneys from the outside. So you can see we've got the sunshades in white that kind of provide shade to the interior spaces to really avoid some of the direct daylight or direct sunlight and glare to the interior spaces. So we get the nice sort of diffuse natural light coming into the interior spaces. And then you can see the thermal chimney at the top. So again, we've got the clear glass at the top to really bring in heat on the upper portion of the thermal chimney, and then that sort of pulls the air up and out of the space so that the hot air kind of exits out the louvers at the top of that thermal chimney. So we're here inside the office bar. You can see we've got a lot of the open office space kind of in direct proximity to the windows to the outside. So a lot of that natural daylight from the outside is able to come in kind of deep within the space. And then we have some of the more private offices kind of located in the middle of the bar, the office bar, so that the walls around the private office space don't sort of prevent the natural light from reaching in throughout the open office areas. Again, we've got the white solar shades on the exterior of the building on the office bar, similar to what we saw when we were over walking around the maintenance bar. And then again, we've got the operable windows that are down below, so pulling the kind of cool outdoor air in through the space. You can see right now they're closed. So we're a little bit later in the day, so kind of the building system has a temperature gauge, so when the conditions outside start to warm up, those operable windows automatically close. You can see we've got the fans in the space as well, and then there's also a roof monitor up there bringing that natural light into the space, and that area also functions as a thermal chimney.
In concert with everything, the lighting, the mechanical systems that you have just discussed with the natural ventilation are all tied into the BMS system, the building management. So the building management system is key to this in that it manages when the fans come on, when the windows close. There are also operable windows up in the light monitor that help pull that air up and out. So those open and close dependent on the temperature inside and outside. When the inside temperature gets to that optimal zone, then those close, and then the fans can start up later to help mix that air and keep it from stratifying. The lighting as well is all daylight controlled. When they're in here most of the time during the day, you have the great views to the landscape we reviewed earlier. The lights are typically off because there's enough daylight that they don't need to use energy for that lighting in space. And one of the key things that I think we learned on this project was the buy-in from the staff and the campus early in the project. I know you and Level 10 got together early and promoted this idea of zero net energy and how can this building function and live along with the occupants.
Yeah, we mentioned it a little bit when we were over at the maintenance bar, talking about kind of the benefit of getting sort of the end user input early on as we were designing the project. A little bit later from Dennis Astle, but one of the primary drivers to reach the performance goals for the project was getting sort of the early direction from Palomar College to have a net zero energy building and kind of achieve these really great sustainability and performance goals. So getting that direction from the beginning from the client was sort of instrumental in kind of guiding the design process throughout, so that we were able to, from the beginning, really look at the passive strategies like maximizing the natural ventilation and the natural daylight to really reduce the energy consumption, so that with the PV panels that we have on the roof, we're able to achieve that net zero energy performance.
Right, and I think we've noticed that on other projects where we don't have that early buy-in, you design a project, but then in the end it doesn't follow through.
Mm-hmm.
Where this project is one where it's maintained,
Mm-hmm.
they actually get excited about the performance,
Mm-hmm.
want to see it do what it's supposed to do.
Right.
So without that early buy-in, you've got people in other projects where they're turning the lights on, they're, you know, shutting off the natural ventilation systems.
Mm-hmm.
You know, in this case, they're really excited about it,
Mm-hmm.
and it was part of the success.
Yeah. And then we'll also talk a little bit later about the Living Building Challenge process, but really this building has been in operation for over a year, and it's already been able to demonstrate that it's collected more energy through its PV system than it's used over the past year. So this building is in a position to actually say it's already achieved that net zero energy goal through its performance, which is really, really great.
Net positive.
Right. Mm-hmm. It sort of is able to collect more energy than it used.
When it came to sustainability for the project, we actually, when we went out for our RFP to select our design build team, we didn't have a big, large goal. We just stated that we wanted the building to be a very sustainable and very low maintenance. Once the team was selected, the level 10 BNIM team, in some of our first meetings, we started talking about sustainability. And it really came from the team when we started talking about, well, how sustainable do you want it to be? And I kind of bounced back, well, how sustainability can you guys make it? And when the team said we think we can get net zero, you know, then it was like, oh, if you can do that, hell yeah, we want to do that. We have a mandate in California that all buildings in the community college system need to be designed to net zeros starting in 2020. We started this project prior to that, so we wanted this to be our first project that attained that, and the whole team worked so well to achieve that goal, came up with the innovative ideas that has made it possible. And that kind of led to a lot of the interaction with the staff. We, I think, did a very good job taking all the different departments, all the different groups, say the folks that would in our wood shop, the warehouse, the plumbers, electricians. They each got to have input into their individualized spaces to make sure it worked really well for what they did. That went on throughout the design process. We kept coming back to them, making sure, hey, this is our layout. Does this work for you? Doing some tweaks. And it's worked really, really well. The guys really appreciated that they got that much input into the design. And it's really reflected in how the building has performed. I can tell you from experience doing lots of buildings on campus, once a new building is done and the guys get to start working in it, our maintenance staff usually comes to me with, well, why did they do that? That was stupid. On this building, not one comment like that. And for that to happen with maintenance guys is a real compliment to the team for doing a good job. We've had no complaints. I can tell you from my perspective, coming from our old facilities that had no natural daylight, kind of dark and dingy, moving to this has been just wonderful. It's such a nice building to work in. We have the views of the greenscape and the landscaping, and the amount of natural daylight is just phenomenal in this building. And it's everyone's attitude has changed for the better. It's been a really pleasant move. Like I said, not one complaint from any of the staff. So my compliments to the design team.
Jeremy, you're on mute.
Yep, I am. Sorry. Thanks. Well, thank you for the team for getting that together. You can tell that this is an urban site with all the traffic noise and so forth, but I think that was really helpful to be able to see inside the building, and especially to actually see these, what forever to me have been these white frames over the building, actually fully engaged with the solar PV after more than a year of operation here. So really great. Thank you to the team. Before we jump on beyond this, I wanted to see if there were, if we wanted to cover a couple of questions first. So a few of the questions that I'm seeing here for the team is, number one is, how did you deal with plant irrigation under the solar canopy? Was anything special required?
I guess I'll answer that. The cisterns provide irrigation to that area, as well as the little rivers that were mentioned in the tour. When rainwater does fall into those areas, it flows into the area beneath the canopies. As well as the cisterns, they have the piping system, a drip system attached to them. This water is then pumped into those areas.
Yeah, other than that, the irrigation for the plants within that courtyard are pretty standard, low flow irrigation, NP rotators. The amount of water is just adjusted based on the amount of rainfall and how the plants are doing. Nothing special.
Thanks, guys. So the next question I see, I'm going to just stick with kind of in themes here. The next one I see regarding landscape is asking, the landscape seems extremely mature and well established. Was there anything special done? Or is it just the luxury of the San Diego climate?
Well, I'd say it's primarily the luxury of the San Diego climate. I wish we could claim more responsibility. But, you know, as long as you give them water in Southern California, things tend to grow really, really well. Even unfortunately, the weeds grow just as well. So, you know, that's the biggest issue we have. But those plants that you saw in the video are about 2 years old.
Great. See, so there was a question about the terracotta panels. Dennis, maybe you can help us with these. Were those produced domestically? Were they sourced from Europe, which is pretty typical for terracotta?
Well, so they're concrete tiles by NBK. I don't remember where they were sourced exactly, but I remember there was a 12-week lead on them. So let me look into where NBK manufacture those, and I can get back to the team.
Okay. And then another question here is regarding how the staff has adapted to the new facilities, and have the high density shelving systems presented any unexpected challenges?
The staff has really taken to the building well. As I said in the video, really no complaints. Things are working out really smoothly. The high density storage system hasn't had very many problems. We had a few hiccups with some bad sensors that caused some downtime that needed to be fixed, but those seem to have been resolved now. But using the system has not been an issue. They haven't even damaged any of them yet, which is impressive. That's really nice to see. So I think they're taking pride in the new space. The interesting thing, you know, the facilities has been back pretty much during the entire pandemic shutdown because we have to still maintain the campus. And we've been getting deliveries of packages for the district, and we receive, you know, mail and deliveries for the entire district, not just this main campus. We have 4 other campuses. And because we were so efficient with the high density system, they've been able to hold all that material and not spill over into any other space. So unintended, well placed design feature that has really helped us get through the pandemic.
Cool. And then the last question for us, for right now anyway, is about the total campus square foot of buildings being maintained. Do you know that rough number off the top of your head, Dennis?
Oh my goodness. On this campus, we are at about 800,000 for the San Marcos campus.
800,000 square feet.
Yes.
Gotcha.
And the built area of the campus is about 80 acres.
Gotcha. Great, thank you. So we're going to jump next to how does this translate to the Midwest?
Jeremy?
Yeah.
I see a couple questions in the chat as well, if you want to.
Oh, in the chat. I was just looking at the Q&A. Okay, so the two here are about how does this incorporate equity? And I'll go ahead and take that one. There are several aspects of equity in this building. First and foremost is around accessibility. So this goes pretty well above and beyond standard ADA access, and is looking to both what's happening in the building and around the building, but all the pathways that are then connecting to the neighborhood as well are making this a place that the public can get to, where you're able to see and engage with the building, have access to outdoor space, access to edible plant systems, and natural systems. Then the other aspect of it is actually one of the last pieces that we're trying to complete for our Living Building Challenge PETAL certification, which is that at least one of the team has to certify or label under the JUST labeling system. And so BNIM is currently finishing our process to establish our initial JUST label as part of this process. So it's about making sure that your team, the building, and the operation of the facility are considering equity across a broad spectrum. And does anybody else have anything else to add on that? Okay. And then there's another question here I see that's probably for Robert, and that is, you mentioned using ceiling fans in conjunction with solar chimneys. Do the fans target the warm air up into the chimney?
Actually, that's a no. They are integral to the HVAC system, and heating and ventilation and air conditioning for this building is primarily natural, and this is for both buildings. This is the administration building and the warehouse building. They both have ceiling fans, and that's just one step in the process. In the early morning, things may be closed up because the temperatures are fine. Ultimately, they open up the louvers in the bottom and the louvers in the top to allow that solar chimney to take effect and to draw cool air through the building. As the buildings heat up, the solar fans, or not the solar fans, but the ceiling fans then turn on. They come on as the next step in the process, and they allow the air to circulate within the room. Ceiling fans have an ability to basically cool down a space and make it feel cooler than it truly is just by that air movement. And so we can reduce the amount of other ventilation that may occur in the room. The administration building or the office block actually does have a VRF HVAC system that could come on in extreme days, but I'm sure Dennis could tell us how often they use that. It may not be very much, because the natural ventilation system is quite effective. But again, the ceiling fans are not meant to push air into the solar chimneys. They're meant to work with the complete system.
And Robert, remind me, I don't think I could rattle all of the comfort factors off, but there's a clothing factor, there's an air movement factor, humidity.
Correct. Yeah.
What are the other ones?
All those temperature levels, which are basically around 75 degrees, or it's 75 degrees for the building. There's a range that we designed to that's a little bit different, and occupants need to buy into that comfort range. And we talked about that during the tour, that you have to get that buy-in ahead of time. Otherwise, people are going to walk into a building that they're used to being at 72 or even cooler, and they're not going to allow the systems to operate as they're supposed to. So once they get used to the fact they're have a range of comfort between whatever it is, 68 and 75, that helps the system.
Great, perfect. So we'll save some time at the end if there are any other questions about this or the next section. But thanks for the quick answers, everybody. So we want to again, as I said at the beginning of this session, that we didn't only want to talk about a building in Southern California that can achieve this. We wanted to figure out how does this translate to the Midwest in terms of strategy, technology, et cetera. How do we do this in a place where you have extreme heat and extreme cold? And so I think before we start talking about specifics in the Midwest, let's maybe take a step back and look at some of the priorities that went to work on the Palomar project so that we can understand where just the basic building blocks of this approach can be translated to really any climate. And so those strategies I've left on the screen here for a little while we've been answering so that folks could have a chance to read through and absorb them. But number one is really right sizing the project. It's making sure you're not building more than you need or spaces that are overly redundant so that you're not conditioning spaces that aren't needed. Considering the time of use and time of day for each program element. Are there opportunities to shift schedules and share space? Could you look at collaboration and storage being combined in ways that between different departments they might not have been when they were in separate buildings? Thinking about outdoor space for those in the Midwest, certainly the much narrower number of days per year, but thinking about those outdoor spaces that could double as gathering and meeting spaces, either in addition to or in lieu of some of the interior program. Building orientation and siting is really critical. Where you're providing shade, when you guys got to the that solar cover between the two buildings, and that you had that really lovely shaded area, that to me as a design pattern in the Midwest seems like the place this time of year you'd automatically go to. Ashley, can you mute, please? And then not only stopping with the right sizing for the building, for the structure itself, but applying that then to the hardscape too, so that you're giving the landscape and the passive cooling and humidity that the landscape can help mitigate, and as well as water, do some of that work for you too. And so you're not creating more hardscape or blacktop or even white top than you need. But trying to control those things first. So getting the size of the project right is number one. Number two is focusing on those passive and efficiency strategies. So whether it's passive heating and cooling through natural ventilation and additional operability, as Robert was saying, adding that little swing factor for having the, I know I can go open a window, so my comfort range is going to be a little bit broader than if the only temperature control I have is a thermostat. Facade shading with structure and landscape. So passively shading the facade, especially for extreme heat. And then focusing on equipment efficiency. So once you've done those passive things, with what's left, how can you be the most efficient with what's left there? And then the third priority after you've done all of that is the last thing you want to do is come at renewables. So once you've got the size of your footprint, of your energy footprint right, you can go about starting to set an energy budget where you're both looking at an efficiency standpoint and a renewable capacity standpoint, and finding out where that sweet spot is, both for the budget of the project, but also thinking about the sort of push and pull of what it is you want to showcase. The renewables tend to be one of the most expensive parts of a building. So you really want to control that and do that as your last step. And finally, I think just to mention how it's been used here, that thinking about renewables not only as something that sits on the roof and is out of sight, out of mind, but as something that can actually provide an additional service, such as adding additional shading to the building, creating those kinds of shaded breezeways for additional comfort. So those are some of the big parts and pieces. And just, I guess, one more that I wrote down during the virtual tour there was setting clear goals at the beginning, working in dialogue with each other to be really clear at the beginning of a project what what the design and construction team's goals are for a project, and then sticking with it. And then maybe the last one, Robert, picking up on something you said, in addition to that, was about training and engagement with the operators and staff. So it's not just a design team coming up with a whiz-bang facility that nobody knows how to operate, but really working with the owner and operator so that there's that full level of buy-in and understanding of why the system is the way it is. So to talk about a couple of examples in the Kansas City metro area, for those who are in California tuning in, who might not be able to find Kansas City on the map, there it is on the top right. And I think it's important to note that we are a city that is straddled by a state line. So you can see on the bottom right here, the Kansas and Missouri line. And the Johnson County Community College is a suburban community college to the southwest of Kansas City, Missouri. And the Metropolitan Community College Blue River East campus is about the same distance to the east of our campus in a much more rural area. And so we're going to talk briefly about each of these. I will say we are waiting on our panelist for the Metropolitan Community College, who is waiting in line to pick up his kids. So if he's not able to join us by the time we get there, I'll be happy to cover what we need there. So let's start with Johnson County Community College, the Career and Technical Education Building. And I know I've got a few colleagues on who worked very directly on this project. So if you want to type anything in that I miss to the chat, I will pick that up. So the Johnson County Community College Master Plan is in front of you here, quite a fairly large suburban campus. And the CTE building is along the far west end of this campus. And it replaces what used to be just a tennis court and a portion of surface parking. And as such, created really a new gateway into the campus itself. So similar to the Palomar project, something that's kind of front and center for visitors, for guests, for students, for faculty. And so a lot of the consideration for the building form was not only about energy efficiency, but was about creating that sense of arrival and creating that pass-through space so that you can enter into the campus through a really important and beautiful space. And so just to talk in brief about what's included in this particular building, it's a two-story structure that is focused on looking at the left first, which is the first floor. On the bottom here, I think you can see my mouse, is the automotive lab. So this is kids learning how to be mechanics and, with car lifts and so forth. Continuing education labs associated with those. We have teaching centers and an HVAC lab on the north end of this bar to the north. Classrooms kind of scattered throughout, an electrical lab. As we go up into the next level, we have an administrative suite and office and social commons, then computer labs. And we also included a rooftop solar lab. So similar to Palomar, there was an intent to actually cover part of that entryway with PV, so that as you come in, you're really greeted by that as part of that. But because this is a place where we're teaching students how to work on mechanical systems, how to wire an electrical panel properly, and so forth, the idea here was to actually provide direct access to students to have a portion of that array that they can take down, put back up, try different panels, try different orientations. And so thinking about then the overall sustainability strategies on this project, we began with a campus sustainability approach. So looking not just at this project and this building, but looking at the whole campus in terms of open space and green space, access to renewables, native plantings, and much more. We also looked carefully at building orientation and shading. On the bottom right here, you can see some overlays between summer and winter shading and how that affected both the shape and orientation of the building. High performance facade, so using an insulated precast panel, as well as perforated metal and metal panels along this building. Building the solar canopy, which you can see in a few of these different views over this entryway. Incorporating a native landscape, providing building systems that are integrated into the curriculum as accessible components, as I mentioned, being able to get at that solar array. And I think it's something that especially surprised me and delighted me on this project was that this campus has a student-led sustainability fund where the students self-elected to charge themselves an extra amount per credit hour that then they can put towards a campus project or initiative that they want to prioritize. So in this case, they actually prioritized adding additional PV to both this project and a second project that we worked on at the same time for the Fine Arts Building. And then finally, and I'm gonna spend a little more time on this in a moment here, but iterative modeling with the construction team so that we can get detailed analysis as we're going through the design process is really critical. So with that in mind for this project, as a Midwestern project where we're looking at probably 10 to maybe 20 days out of the year where it's more than 100 degrees out with high humidity, and then we've got 10 to 20 days per year where it's either at or below zero with really low humidity. The putting a lot of attention into the envelope itself so that we're keeping the heat out in the summer and we're keeping the heat in the winter was really critical. So all I'm showing you here is a very early energy model that we worked through with our energy analyst, and which told us that kind of what we knew already, that the space heating and space cooling were really going to be the drivers here. But while that might immediately make you think, oh, we need to focus on the HVAC system first, really here it's about the envelope. It's about controlling that heat flow from one place to another. So looking back through our discussion and dialogue, we reduced the total glazing on this building to an average of just below 30%. Average across all the faces, whereas 40% is an industry average for commercial buildings. We also made improvements to the slab, wall, and roof insulation systems, and then also made for what glazing, the 30% of glazing that was left, made very specific improvements to the U value and other performance characteristics of that glass. So that was first and foremost, was let's get the envelope right for our climate. That's really what we need is to be able to hold out those harsh weather patterns and contain the conditioned air that we've got. So next was looking at then the HVAC and lighting systems. And so using a variety of approaches there, including tapping into some of the campus chilled water systems, we were able to reduce our heating load on the building by about 45% and improve our cooling efficiency by about 42%, and then lighting power density down by about 52%. So lots of good things there. And while service water, if you look at the little bars on the left, are not a huge factor, I thought it was especially interesting that by focusing on water efficiency, especially for our service water places, we were able to save about a third of the energy associated with heating that water simply by being more efficient with the water. So there are some trade-offs there, but I would say that those are probably the big factors that had kind of the biggest impact on the success of this project. So the net result was a 48.3% energy reduction based on the way that LEED requires us to calculate it, which is cost, and giving us some penalties for the fact that, for example, students are firing up air conditioning systems while they're training on them. 27.4% of the energy that is used is provided by these on-site renewables that you can see up here on the left. A lesson learned with putting renewables over an entryway in the Midwest is when it snows and freezes, you've really got to work through what you're going to do about ice on that. Not something that had to be considered for a Southern California project, but something that was pretty critical for us to work through here. And then ultimately the campus provides 100% offset through a campus agreement with our local utility provider. So this is new wind being added to our regional power pool as a result of this agreement. And we are in the last stages of getting approval for what we anticipate to be a high LEED version 4 silver certification on this project. So I'm going to check here before I move on to see if Jeremy Kim, have you joined us? There you are. Are you able to talk? I'm not hearing you right now. Connecting audio. Bear with us just a moment here. Hi, Jeremy, are you there?
Hello.
Hi, can you hear me?
I can.
Great.
You able to hear me?
We are, yeah.
Hey.
Perfect timing.
Sure. A litany of apologies to make. First of all, on my appearance. Second of all, on my background. Third of all, on my tardiness. Who knew that kids pickup would take so long? The first day of summer school. And as you would say, Jeremy, there are numerous opportunities for substantial improvement.
All right. No problem. Thanks for joining us.
With that, well, thanks for being patient.
We're ready for you.
Okay. My name is Jeremy Kam. I'm an architect here at BNIM. I've been working for the past year and a half on a project for the Metropolitan Community College of Kansas City. They have been relatively dormant with their building program over the past couple of decades and have recently launched 3 new major capital improvement projects all simultaneously, and this is one of them. The image that we're looking at is taken about a month ago. The building is under construction. It'll be complete in October of this year, and our CM at risk is McCown Construction. Jeremy, if you could go on to the next slide. So the program of this building is kind of interesting. It combines several different functions into a single roof, under a single roof. And it's a technical training building, so they focus on certification for CDL, so truck drivers, logistics and warehousing, which is forklifts and things, the sorts of activities you would see going on in your nearby Amazon warehouse. They have a line work program, which involves everything dealing with line voltage on poles and in transformers. And then finally, this is the home for the Great Plains OSHA Education Center. So all of these under a sheltering roof in a single building. This is a view of the site pre-development, or I should say pre this development. Really the center third of this image is MCC's property. And you can start to see that we're right at the seam or the threshold between a rural area and a kind of exurb of Independence, Missouri. So in the development of our architecture, we took those considerations into account with the typology that we used. Some things to point out on this site plan. You see a lot of flat work on their site. That is existing training. The large square in the center of the image is meant for CDL training. They do a lot of different maneuvers and backing up and things like that. The host of intersections you see to the southeast of that is used by MCC's Public Safety Institute. That course and the sort of brown rectangular patch that is immediately adjacent to the pond are meant to instruct PSI candidates how to drive under adverse conditions. This The one that Jeremy is hovering over here, interestingly enough, is called a skid pad. And that pond is not natural. It was made to feed water into the skid pad. Basically, it's a very shallow bathtub that you practice skidding over in your vehicle. It worked briefly, according to MCC, and has been out of commission ever since then. So in the meantime, that pond remains and has become an interesting habitat for native and migratory species all around it. So we go on to the next slide. Another interesting feature about this property is that it is solidly within a floodplain. You can see as a point of reference that slightly angled square there in the center, just to get you oriented. So this was something we needed to deal with in siting the building. We tried to push it as close to the existing roads as possible, which on a pancake flat site is about as high as you can get, and then build the topography up from there. But trying to do that with a light touch and in as small an area on the site as possible. So going to the next slide. The general building site plan. So again, using that angled square as an orientation point, we are hugging the two roads. The building is shown in orange. It's an extraordinarily simple floor plan in that our kit of parts, which we used in the interest of cost and speed of construction, is pre-engineered metal structure. So that starts to suggest a very simple and straightforward building, and in fact dovetails well with the typology that you typically see out in rural and industrial areas on the outskirts of town. So it's a sort of, we think of it as an enhanced version of a standard pre-engineered metal vernacular. Let's go on to the next slide then. Looking at the plan of the building itself, the diagram is bifurcated north and south, so south being the bottom of the screen here. There are several different functions that take place in this building, some of which are classroom-based in that they don't require high ceilings, and some of which are more hands-on activities or the storage of vehicles, which do require high bay space. So the classrooms are oriented on the north side to avoid harsh glare and to provide opportunity for diffuse natural light. And the high bay then is on the south side of the building primarily. We can go on to the next. So I'm going to show a series of views of the project and just some overlays to give a sense of a few of the strategies that we employed on this project. A few things to point out here from the north looking south, the first of which is the location of that glazing. You can see a stripe that kind of goes off toward your left-hand side. That's where the classrooms and instructional spaces are. The main entry lobby is in the foreground off to the right. And then there is a ridgeline of clerestory. The ridgeline of clerestory I'll talk about in a couple of slides, but for the most part, we're trying to orient the majority of our glass toward the north. As Jeremy said, the envelope is a really important thing to get right in this Midwestern climate, especially to keep out a lot of heat infiltration in the very hot summer months. So go on to the next one. It didn't show up very well, but what I was attempting to illustrate here in the foreground, we have a very large site and there is an awful lot of impervious area on it. The goal of our project is to manage 100% of the stormwater on site. And so we are doing that with a combination of constructed wetlands and native plantings around the built area. On to the next one. On the west facade, on a day like today, when my computer says 95 degrees and sunny outside, that west facade gets a beating. To counteract that, or to kind of work with that, we have, you often see strategies where there's glass and then there's something in front of the glass like a scrim to mitigate sun or direct solar gain. In this case, we pulled them quite far apart and created a breezeway in between the two layers of facade that acts as the building entry. The next slide. So a couple looking in the opposite direction, we can see that breezeway off on the left side of this image, and then a few overlays on from this direction. Here, when it comes to glazing, we are being very strategic with where we locate it on the south. The low line of glazing that's on the right side of the image works in concert with that clear story that we looked at a couple of slides before. So next slide. Jeremy had mentioned of the principles that are the common thread that tie these three projects together. One of them is thinking about renewables last. So I'm going a little bit out of order here, but just because the view is good, we have an incredibly large roof on this project, which is incredibly well positioned to receive photovoltaic panels. The project, because we were able to drive down the EUI and the demand for energy, only requires about an 80 kilowatt installation to become net zero energy. It is MCC's plan to implement this. We're still trying to convince, well, we're working with them to determine when the most fortuitous time in the project is to do that. But it only, in terms of square footage, takes up about a quarter of this roof. That's all you need from a solar standpoint to get to net zero energy with an EUI as low as we have. And that EUI is around 14.5. Here again, my color isn't showing up very well, but this is the another indication of the wetlands, which is a low point on the site. We're collecting water. And so you'll walk right past, we're actually on an entry sidewalk going toward the building where we've parked our car or perhaps taken a ride share and are walking along the sidewalk. And there will be interpretive signs along this pathway that tell you about the wetlands as you're moving along them. Next slide. Moving inside the building, we saw the diagram earlier where low instructional space is on the north side of the building. That's indicated in that box that you see there. But it's all kind of under this sheltering roof. So there are varying levels of enclosure with this project, similar to JCCC, similar to Palomar, where we have areas that are sheltered but exterior. We have, on the opposite end, fully conditioned interior spaces. And then there's this area in between, and that's the entirety of the high bay space. It's a heat-only space. We are ventilating it. And again, you see off to the left-hand side, the low operable windows, and then up at the clear story, those two elements work in concert with the low velocity fans to encourage air to enter low, cool air to enter low and migrate up and out of the ridge as a passive strategy. In addition to that, and I think it may be the next slide, active strategy is that hydronic radiant floor, which extends throughout all underneath the concrete slab and keeps it relatively warm during the winter time. The nature of the space is not to have it at a very tight set point, but rather to allow it to fluctuate a little bit. We're talking vehicles here and work being done. So it is able to not need the amount of cooling that the classroom does. Gosh, I really flew through that, but I think that's more or less what I had to share.
Great, thanks so much, Jeremy, and we're just about to time here, so perfect, well done. I do not see any new questions coming in the Q&A or the chat, unless I missed something. So
I have a contractor question on this project.
Sure.
Total cost or dollar per square foot? Good. Sure.
I meant to look that up before this meeting. It's in the mid 200s.
Wow, that's great.
But I don't have an exact number at my fingertips, unfortunately.
But you can see in both of these project examples where it's using the same types of strategies that we used at Palomar, but adjusted for a hot, humid, and extreme cold climate here in the Midwest. So it's simply to say that some of those same strategies can translate very seamlessly, but the way that we get there might change a little bit. The nuts and bolts of how we accomplish the same thing can change, but these are examples of 3 community colleges, Palomar showing an excellent net positive and just a great project to share. And I wanted to make sure we included these last 2 to bring it home for those in the Kansas City market. Megan, do you want to close us out?
Sure. Again, I just want to thank BNIM and the construction team for putting this great dialogue on. It was very interesting, not to mention that, it's almost 100 degrees here. So all of these different systems and design that you put in is very much needed these days. Myself, along with Ashley and Galen, want to thank everyone for joining us in the first of the series of Show Your Work. Please stay tuned for our dates on the upcoming series. We have Helix that will be highlighting the Marshall Hall project later this summer. In addition, we are moving forward with an in-person Design Excellence Award ceremony this fall, which would be November 5th. And the call for entries is now open, and those are due on June 30th. So if you do have any questions, please don't hesitate to reach out to Kristen Demetz. And thanks again for joining us, and we look forward to seeing you at the next session.
Thanks again. Bye all.